So, have you ever found yourself needing to answer a question that first requires you to answer another question? You know, in the world of data, that happens all the time. And SQL's answer to this puzzle is something called a subquery. It's an incredibly powerful way to layer your logic, but let's be honest, it can get a little confusing. So, in the next few minutes, we're going to clear it all up, from the basics all the way to the really clever stuff. Here's the game plan. First, we'll break down what a subquery even is. Then we'll see one in action with a real example. After that, we'll meet its smarter, more powerful cousin, the correlated subquery. We'll put them head to head to see the difference. And finally, we'll talk about why this actually matters for your day-to-day work and, yep, even for job interviews. All right, before we jump into any code, let's just start with this one idea. How do you answer a question by asking another question first? If you can wrap your head around that, you've already understood the entire logic behind SQL subqueries.
Okay, so what is it really? Well, it's exactly what it sounds like, a query that's tucked inside another query. The database is smart about this. It always runs the inner query first, figures out the answer to that little question, and then it hands that answer off to the main, outer query to finish the job. It's a really clean two-step process.
All right, theory is one thing, but seeing it work is way better. So let's walk through a super clear, step-by-step example to see how this plays out in the real world. Okay, our mission is simple. Find the student with the highest marks. Now, if we were writing the query, we'd start with something like select name from students where marks equals what? We don't know the highest mark yet. So that's our first question. And that's what goes inside the parentheses, a separate little query to figure out the maximum marks. And here's the data we're going to be working with. Just a simple table of 4 students. As you can see, Neha is our top scorer here with a solid 90. Keep that in mind. So, check this out. This is how the database thinks. First, step 1, it completely ignores the outer query and just runs the one on the inside. It looks at the marks column, finds the biggest number, and gets the value 90. Then, for step 2, it takes that number and substitutes it back into the main query. The outer query never even knew there was a subquery, it just gets a value. So the query becomes a simple, find the student where marks equals 90. And that, of course, leads us to step 3, our final answer, Neha. But hang on, here's a classic gotcha. What happens if that inner query doesn't return one neat little answer, but a whole list of them? Well, if you try to use a simple equal sign to compare one value to a list, your database is going to have a problem with that and throw an error. And this slide shows you the fix perfectly. So on the left, imagine our subquery asks for all ages over 20. That would give us a list, 21 and 22. You can't say age equals 21, 22. It just doesn't make sense. The right way to do it, on the right side there, is to swap out the equal sign for the in operator. That just asks a simple question, is the student's age in the list of results we got back? Problem solved. Okay, so that's your standard subquery. It's self-contained. But what if your inner query actually needs a piece of information from the outer query just to do its job? Well, for that, we need to level up to a much smarter tool, the correlated subquery. Now, this is the big difference, so listen up. A regular subquery runs one time, that's it. A correlated subquery, on the other hand, runs over and over and over again, once for every single row of the outer query. You can think of it like a conversation. For each row, the outer query taps the inner query on the shoulder and says, hey, here's a value, go run with it. So here's a perfect problem for this. Find all students who scored higher than the average of their own class. You see, a simple subquery could find the average of all students, but not the average for just Class A, then just Class B. Notice that little s.class in the inner query? That s is a reference back to the outer table. That's the correlation right there. It connects the two. And to make this work, we're using a slightly different table. You can see we now have students split into Class A and Class B. This grouping is what makes the problem interesting. Okay, let's trace the logic row by row. It's really cool. First, the outer query looks at Rahul. It sees he's in Class A, so it tells the inner query, go find the average for Class A. The inner query does that, gets 75, and sends it back. Since Rahul's 80 is greater than 75, he makes the cut. True. Next up, Amit. He's also in Class A, so the subquery runs again, gets the same average of 75, but this time Amit's 70 is not greater, so he's out. False. Then we get to Neha. She's in Class B. So the outer query tells the inner one, okay, new job. Find the average for Class B now.
The inner query recalculates, gets 75, and since her 90 is greater, she's in. And it does this for every single row in the table. Whew, okay, so we've seen them both in action. Let's just put them side by side so we can really lock in the key differences between them.
So let's break it down. Your basic subquery, it runs one time, period. It's independent, and because it only runs once, it's usually pretty fast. The correlated subquery, though, runs for every single row of your outer query. This makes it way more powerful, but it also means it's slower and totally dependent on that outer query. It's really a trade-off between speed and complexity.
So why are we spending all this time on this? Why does this really matter? Well, it's because these patterns show up everywhere, from your actual day-to-day analysis to the kind of tricky questions you'll definitely get in a technical interview. And once you see the pattern, you'll see it everywhere. Anytime you hear a question like, find the employees earning more than their department's average, or find customers who spent more than their city's average, that little per group comparison is your signal. It's a classic use case for a correlated subquery. But, and this is a really important but, a word of caution. Because that inner query has to run over and over, correlated subqueries can be really slow on big data sets. I'm talking millions of rows. In a real-world project, you'll often see developers reach for other tools, like a join or something called a window function, to get the same answer much, much faster. And let's end with a golden nugget, especially for interviews. If you ever hear that phrase, find the values above the average per group, a little light bulb should go off in your head. That is the textbook signal for a correlated subquery. Knowing that doesn't just help you get the right answer, it shows you understand the underlying logic. It really makes you wonder, what other common questions are just signals pointing to a specific SQL tool? Definitely something to think about.